Okay, so up to this point in time, we have talked about the areas of rectangles, squares, and parallelograms. Today, we are going to focus on the areas of triangles. As you can see here, the area of a triangle equals half the product of a base and the height of that base. Just kind of give you a quick rundown on why that is true. If we start off with a rectangle, we know that we can find the area of this rectangle by multiplying its base and its height. So the area will be the base times the height. If we were to draw in a diagonal, that's going to divide this triangle up into, sorry, not this triangle, this rectangle rather, up into two congruent triangles. So they would have the same area. So the area of one of those triangles is going to be half the base times the height. And this is going to be the case for all parallelograms. If you were to take and to divide any parallelogram up into two um, triangles, those triangles are going to have the same area, and the area is going to be half of the parallelogram. And to find the area of any parallelogram, it's base times height. So that's where this formula comes from. Now, the location of the height is dependent upon the type of triangle that you have. So if you think back to the parallelograms video, we said that the base and the height have to be perpendicular to each other, and that's the case with triangles as well. So remember, the height is always perpendicular to the base of the triangle. Now, depending upon the type of triangle that you have, and also depending upon the information that you have, you might have to draw in an altitude so you can have that base and height be perpendicular. Now, for a right triangle, it's really nice and easy because the legs are perpendicular to each other. So the height is just going to be one of the legs. You can choose. And then the base is going to be the other leg. Oops. So finding the area of a right triangle is really, really easy. We're just going to take the area equals 1/2, and it's just the product of the legs. So 7 centimeters times 2 centimeters. So the area is going to equal 7 square centimeters. So like I said before, just a minute ago, finding areas of right triangles, really straightforward, really easy. Starts getting a little bit trickier when we get to obtuse and acute triangles. Now, remember, all triangles have three altitudes. All right, so you can really pick and choose where you want to draw the altitude depending upon the sides that you're given or the angle that you're given. In this case, this obtuse triangle has, you can draw this altitude right here. But that's not really helpful because we don't know what the length of this side is, and it's really going to be difficult for us to figure out what the height is. So your other option would be to draw one of the altitudes that's on the exterior of the triangle. So here, what I would do is consider drawing this altitude. And it's going to be a little bit easier for us to figure out what the height is now that we know this. This interior angle is 150. This exterior angle right here is a linear pair, so that's going to be 30 degrees. This side is actually the hypotenuse, so we should be able to find the height by using the properties of 30, 60, 90 triangles. So in this case, the height is located on the exterior. Could be located on the interior, depending upon, again, like I had mentioned before, what information that you're given. Um, but again, on this one, it's on the exterior. Has to be perpendicular to the altitude. So in this case, the base, if we were to extend it, that line that contains the base is perpendicular to the altitude. So for this one, we actually need to figure out what the height is. the height is opposite a 30-degree angle in a 30, 60, 90 triangle, so it has to be half the hypotenuse, so the height is 4. So the area is 1/2 the base. Now the base is just the length that you see in the triangle. It's just this piece right here that you're given, so 11 inches. So that's 11 times the height, which is 4 inches. So the total area is going to be 22 square inches. So when you're dealing with a triangle, an obtuse triangle specifically, all right, you have to kind of pick and choose where you're going to place that height. Could end up on the interior, could end up on the exterior. It really depends on the information that you're given. For us, it made more sense to draw the altitude on the exterior because that's the only way we're really going to be able to find the height in this case. All right, I want to look at the last one, which is an acute triangle. So again, all triangles have 3 altitudes. For me, the easiest one right now, I think, to draw would be this one right here, because that's going to break our triangle up into 2 triangles, one of which is a 45, 45, 90 triangle. So finding the height is going to be pretty easy. For an acute triangle, the height will always be always in the interior. The base, again, is going to be perpendicular to the altitude that you draw in. I think I spelled altitude wrong. Let's try that again. Altitude, that's better. So in this case, to solve this problem, we actually need to determine the height. So the height is a leg of a 45, 45, 90 triangle. And we know that the hypotenuse is 18 feet. So in a 45, 45, 90, we know that the leg times the square root of 2 equals the hypotenuse. So the height times the square root of 2 is going to equal 18 in this case, because the height is the leg of the 45, 45, 90. The hypotenuse is 18. Here we're going to divide by the square root of 2 and rationalize, and that's going to end up being h equals 9 root 2. So to find our area, it's 1/2 our base. The base is 12 feet, as we can see right there. And then the height we just found the length of is 9 root 2. So if we want the exact answer, I don't know why this is up. There we go. It's 54 root 2 square feet. Realistically, that's not a number that you're going to be working with if you're, dealing in areas. You're going to want a decimal approximation with that. 76.4 square feet makes a little bit more sense. So if you were to multiply 54 times the square root of 2, that's going to give you this decimal approximation. All right, so these are just some things to keep in mind when you're going through and you're solving area problems that involve triangles. Okay, the base and the height need to be perpendicular to each other. If you're dealing with a right triangle, no big deal because the legs are always perpendicular. If you're dealing with an obtuse triangle or an acute triangle, then that's different. You're going to have to draw in an altitude and determine that height with the techniques that we've used throughout the course of the year. So let's go ahead and look at a couple of examples just to make sure that we know what's going on here. Example number 1 says find the area of the triangle. This is an acute triangle. The way that we can tell that is that the two sides or the two legs, this is isosceles, are 10. And then the other leg, or not the other leg, the other side measures 8 units. So we know that this has to be an acute triangle. So again, here we're going to need to figure out what the height is. Since this is isosceles, that altitude cuts the base in half. So we can use the Pythagorean theorem to figure out the height. So h squared plus 4 squared equals 10 squared. So h squared is going to equal 100 minus 16, which is 84. Take the square root of both sides, and we are going to get h equals I'm going to actually simplify this down to 2 root 21. You could take a decimal approximation of this if you wanted to at this point. I'm just going to wait until the end to take the approximation. So the area is going to be 1/2. In this case, the base is this entire base right here. It's 8. And then the height is 2 root 21. So if we calculate this out, we're going to get roughly 36.7 square units. If we look at example 2, we have a couple right triangles. So this makes life a lot easier because we have 2 perpendicular sides. So we have a defined base and height already. So let's find the area of this first triangle. It says find the area of the triangles. So we'll find the area of triangle number 1. 25 is a hypotenuse, and then 20 is a leg. That's actually a Pythagorean triple, so the other leg is going to be 15. So the area of triangle 1, and I'm just going to put triangle 1 for my subscript, is going to be 1/2 15 times 20, which ends up being 150 square units. And then the second triangle, which I'll outline in another color here. Here we go. Okay, that's actually another Pythagorean triple. So 25, 7, and 24. And then again, if you didn't recognize that those are Pythagorean triples, you can always use the Pythagorean theorem to get the missing sides. So the area of triangle 2 is going to be 1/2 7 times 24. So the 2 sides, the 2 legs that are perpendicular, which is 84 square units. Okay, and finally, our last one, we've got an obtuse triangle. And this one's actually really straightforward because we already have the base and the height. If we didn't have one of those, we'd have to figure that out, again, using the techniques that we've learned this year. So area equals 1/2, the base, which is 5, times the height, which is 4, and that's going to equal 10 square units. All right, so really the big takeaway from this, or a couple big takeaways from this video, one is that the area of a triangle can be found by multiplying 1/2 times the base and the height. And the base and the height must be perpendicular to each other. Okay, so they have to be perpendicular. So if you're not dealing with a right triangle, you're going to have to draw in an altitude and figure out the length of that altitude, using right triangle trig, using the Pythagorean theorem, special right triangles. Those are some things that you might have to use. Hope this video was helpful. If you have any questions or concerns, feel free to email me or message me through Google Classroom. And we'll talk to you guys in the next one.